properly bond the metal enclosure of your electrical panel, begin by tapping a 10.32 screw hole into the enclosure. This will serve as the connection point for your bonding wire. Next, attach a lug connector to a number 6 American wire gauge, or AUG, bonding wire. Securely fasten the lug connector to the newly tapped 10.32 screw in the metal enclosure. This establishes a direct electrical connection between the bonding wire and the enclosure itself. Run the other end of the number 6 AWG bonding wire to the neutral bus within the panel. Firmly connect the bonding wire to the neutral bus, ensuring a tight and reliable connection. This step is crucial for providing a low impedance path for fault currents. Additionally, it is important to bond the ground rod to the enclosure. This can be achieved by running a separate bonding conductor from the ground rod to the metal enclosure. The size of this bonding conductor should also be appropriate for the system, typically number 6 AWG. Securely connect this bonding conductor to both the ground rod and the metal enclosure. This connection ensures that the ground rod is effectively integrated into the grounding system. The purpose of bonding the metal enclosure is to provide a safe path for fault currents back to the source. In the event of a fault, such as a live wire coming into contact with the enclosure, the fault current will flow through the bonding wire back to the neutral bus. This flow of current will then trip the circuit breaker or blow the fuse, disconnecting the power and preventing electrical shock. Without proper bonding, the metal enclosure could become energized in the event of a fault, posing a significant electrical shock hazard. The National Electrical Code, or NEC, provides specific requirements for bonding and grounding electrical systems. Adhering to these requirements is essential for ensuring electrical safety. Review NEC Article 250 for detailed information on grounding and bonding requirements. When installing a ground rod, ensure that it is driven deep enough into the ground to provide good contact with the earth. The NEC specifies minimum depths for ground rods, which vary depending on soil conditions. Proper grounding is essential for dissipating fault currents and protecting against electrical shock. The size of the grounding and bonding conductor should be appropriate for the size of the electrical system. The NEC provides tables that specify the minimum size of grounding and bonding conductors based on the size of the service entrance conductors. Always consult these tables to ensure that you are using the correct size conductors. When making connections, use appropriate connectors that are listed for the purpose. Ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical problems. Periodically inspect the grounding and bonding system to ensure that all connections are still tight and that there are no signs of corrosion or damage. If you find any problems, correct them immediately. It is important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth, while bonding is the connection of metal parts together to create a low impedance path for fault currents. Both grounding and bonding are essential for electrical safety. When working with electrical systems, always to energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Always follow the manufacturer's instructions when installing electrical equipment. Use only approved electrical equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Be aware of the potential hazards of working with electricity and take steps to minimize those hazards. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Work in a well-lit area and keep your work area clean and organized. If you have any questions about electrical safety, consult a qualified electrician or electrical inspector. Your local electrical inspector can provide guidance on complying with the NEC and other applicable electrical codes. Remember that electrical codes and regulations can vary depending on your location, so it is important to be familiar with the requirements in your area. The purpose of the equipment grounding conductor, which is the bonding wire in this case, is to provide a low impedance path for fault current to return to the source, allowing the overcurrent protection device, such as a circuit breaker, to trip and clear the fault. This helps to prevent dangerous voltage from appearing on metal parts of equipment, which could cause an electrical shock hazard. When installing the bonding wire, make sure to avoid sharp bends or kinks, as these can increase the impedance of the conductor and reduce its effectiveness. The bonding wire should be run as directly as possible between the enclosure and the neutral bus. Also, be sure to protect the bonding wire from physical damage. If the wire is exposed to the elements or to potential mechanical damage, it should be protected by conduit or other suitable means. The size of the bonding wire is determined by the size of the service entrance conductors. Consult the NEC Table 250.102 for the proper sizing of bonding jumpers and system bonding conductors. For example, if the service entrance conductors are number 2 AWG copper, the minimum size of the bonding wire is number 8 AWG copper. If the service entrance conductors are larger, the bonding wire will need to be larger as well. In addition to bonding the enclosure and the ground rod to the neutral bus, it is also important to bond any other metal parts of the electrical system, such as metal conduits, metal enclosures, and metal equipment frames. This helps to create a complete and continuous grounding system that will provide a safe path for fault currents. When bonding metal conduits, use bonding bushings or bonding locknuts to ensure a good electrical connection between the conduit and enclosure. Bonding bushings are typically used on knockouts that are larger than trade size 1 1/4. Bonding locknuts are used on smaller knockouts. When bonding metal enclosures, use bonding jumpers to connect the enclosure to the grounding electrode conductor or to the neutral bus. Bonding jumpers should be sized according to NEC Table 250.102. When bonding metal equipment frames, use bonding jumpers to connect the frame to the grounding electrode conductor or to the neutral bus. Bonding jumpers should be sized according to NEC Table 250.122. The grounding electrode conductor is the conductor that connects the grounding electrode, such as a ground rod, to the electrical system. The grounding electrode conductor should be sized according to NEC Table 250.66. The grounding electrode conductor should be run in a straight line and should be protected from physical damage. When connecting the grounding electrode conductor to the grounding electrode, use a listed connector that is suitable for the purpose. The grounding electrode should be installed in accordance with NEC Section 250.52. Grounding electrodes can include ground rods, crown plates, metal underground water pipes, and concrete encased electrodes, also known as UFERs. The type of grounding electrode that is used will depend on the specific application and the local soil conditions. In some cases, it may be necessary to use multiple grounding electrodes to achieve the required grounding resistance. The grounding resistance should be measured using a ground resistance tester. The grounding resistance should be less than 25 ohms. If the grounding resistance is greater than 25 ohms, additional grounding electrodes should be installed. Maintaining a low impedance ground path is crucial for the safe and effective operation of electrical systems. By following the NEC requirements for grounding and bonding, you can help to protect people and property from electrical hazards. Remember to consult with a qualified electrician if you have any questions or concerns about grounding and bonding. They can provide expert advice and ensure that your electrical system is properly grounded and bonded. Furthermore, always keep in mind that electrical work can be dangerous. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. Attempting to perform electrical work without the proper knowledge and experience can result in serious injury or death. By taking the necessary precautions and following the proper procedures, you can help to ensure a safe and reliable electrical system. Firstly, ensure the power is off before beginning any electrical work. Secondly, double-check with a voltage tester to confirm the circuit is energized. Thirdly, use the correctly sized tools for the job. Fourthly, wear appropriate personal protective equipment, including safety glasses and gloves. Fifthly, never work alone. Sixthly, if you're unsure about any aspect of the work, consult with a qualified electrician. Seventhly, always follow the manufacturer's instructions for any equipment you're installing. Eighthly, ensure all connections are tight and secure. Ninthly, protect all wiring from physical damage. Tenthly, inspect your work carefully before energizing the circuit. By adhering to these safety precautions, you can minimize the risk of electrical shock and ensure a safe working environment. Remember, electricity is a powerful force that must be treated with respect. If you're ever in doubt, consult with a qualified electrician.